Hi, Ben with Novelux Stereophonic. Thanks for stopping by the channel. Here at the bench today, my device under test is a Denon PRA-1000 stereo preamplifier, and this unit is exhibiting a really strange symptom, and it's only happening in one channel. So I thought this would be a great example for some basic signal tracing. The product that I'm going to be using to make this video was supplied to me by this company.
FNIRSI.
I don't know exactly how to pronounce it. I'll tag that in, but I'm not even going to attempt it. I'm just going to refer to it as FN for now. DSO-510. What this device is a single channel oscilloscope and signal generator, and it's battery powered. So this is kind of perfect for basic signal tracing work. So that's what I'm going to be doing in this video. We'll diagnose this thing, isolate the issue by signal tracing, and hopefully resolve it. So if that sounds cool, stay tuned and we'll get started. Okay, let's start out by reproducing the issue on this device. So I'm feeding a 1 volt peak-to-peak signal from my signal generator into the auxiliary input, and I'm looking at it on this oscilloscope. So what's happening with this is, I'll turn this down, we don't need to hear this sine wave. Right now everything looks fine. I have both channels here, and they're nice and clean. But as I turn up the volume, the channel shown in red starts clipping. I'll do a close-up on the scope so you can see what I'm talking about. So all I'm doing here is slowly raising the volume control, and we'll see as I get higher in output, the yellow trace looks fine, but the red trace starts to clip at the top and deform. And this is kind of a hard issue to diagnose by ear because the volume level is pretty high at this point. So at low volume levels, you wouldn't know anything was wrong with this unit, but as the volume is increased, something's definitely happening. These channels should look the same. So this is the shape that I'm kind of looking for, and we'll use that little oscilloscope to find out where the signal is getting interrupted. Before I start the signal tracing, I wanted to come up with a strategy. So I've printed out the block diagram for this preamp. Unfortunately, this page was all in German, so I had to do a little bit of translation, but now that I understand what the blocks actually do, I can come up with a plan. So I'm going to be working off of the assumption that the issue is after the volume control. Just based on this symptom, it doesn't seem like the volume control would affect it. This is usually a passive attenuator. So the signal is coming in at full level, and then when it hits the volume control, all you're doing is knocking the signal back. This symptom of clipping seems to me like a bad capacitor, a bad IC, or a bad transistor. So I'm going to be looking in the active circuitry that's on the other side of that. But to verify, one of the first places that I'm going to check is right at the entrance to this first stage, the input to this preamp tone control section, and just confirm that my signal is good here. After that, I'm going to use a strategy called half splitting. So there's a few different ways that you can signal trace. You can just start at the back or the front of the circuit and just work your way in steps until you find the issue. But I think it's a little bit faster to do a strategy called half splitting. So if we come in between these two blocks and probe here, if the signal is good, we automatically know everything in front of it is good. So it really quickly isolates it just to this one block, or maybe this noise canceller circuit that's kind of on top of it. So that's going to be the strategy. I'm going to get a base level signal set up on the oscilloscope. We'll probe here and make sure it's fine there, and then we'll probe in the middle here and see if we can isolate it to one of these two sections. Let's take a look at this little oscilloscope. So open it up. It's inside of a little plastic sleeve here. I've already had this open. Got a little screen protector on it. I'll leave that on for now. And then inside of here should be some other stuff. Looks like there's a box with some accessories. On the top here, it doesn't have standard BNCs because it's so small, so they're providing a little adapter here, which can be plugged in to convert you to BNC, which will accept this probe. Looks like it has a little, yeah, there's a little section here that you can put a wrist strap on it if you're, I guess, out in the field with this thing. Let's see what else comes in here. Got just a fun little QC badge. Manual in, looks like Chinese and English. and a USB to USB-C cord. One of the other cool things about this is it has a rechargeable battery in it. So most things, like for me at my bench, I have an actual outlet that has a USB and USB-C jack on it. So this will be really easy to recharge at the bench as I need. Could also work in the car. My car has USB ports and stuff in it, so I could charge this on the go if I took it with me out in the field. Okay, so the first thing I'm going to do with this is turn it on and set it up so that it's producing a test signal and that we can see it properly on the scope. There's actually one more thing inside of the box here. It's kind of stuck in there. This must be for the signal generator. So it's got this little plug and then a plus and a minus alligator clip. So this is how we'll get the signal out of the unit. Okay, let's get this thing set up for the testing that we're going to be doing on this unit. So first of all, I'm going to plug this adapter into the DSO section, and then we'll plug in the probe. It's actually probably easier to lock the probe into the adapter first. Okay, we'll plug that into the DSO. And then we're going to take this other cable and plug this into the DDS section. And then for hooking up to the device under test, I'm going to be using this RCA splitter, and I'll provide links for some of this stuff. So in this case, I'm just going to take the positive and feed it to the male pin on this RCA and the negative here. And I just have to make sure that these aren't going to short together. So if I slide this booty up, it will help so that that doesn't short out against the ground connection here. And then this is the RCA cable that's feeding my auxiliary input, so I can just plug in like this. So that's how this setup is going to work for the signal tracing, and then we'll just be probing around inside of the circuit with this oscilloscope probe. Now before we move forward with that, I'm going to disconnect this and get myself a reference level here on the scope. So for that, I'm just going to take the ground part of the probe and attach it to the black here. And then do that for the actual probe tip. So now I need to turn on the signal generator. This signal should come back through into the scope probe, and we should get a display of a sine wave on the screen. Okay, to turn this on, we just have a little power button right here. It boots up, and there's a slider on the top to choose between the different functions. So the first thing I want to do is actually turn on a test signal. And I want to try to keep this signal the same as what I was doing with my bench equipment. So I'm going to select sine wave, and then let's see, do I have options here? Yes. So I click this once and it brings me down in the option field, and then I can click again to change the frequency. We're going to stay at, let's see. Oh, this changes it over, and then we can do up and down here. So let's get it back to 1000 hertz or 1 kilohertz. Duty cycle I'm not concerned about. Amplitude, I believe this is in peak to peak. We'll find out here shortly. So I need to go, let's see, how do I get down there? There we go. Amplitude, and we want to take this down to 1 volt. See if we can push and hold. Nope, we do have to tap. 1 volt. I'm going to assume that this is peak to peak. We'll confirm that a little bit later. So I did end up confirming that when this one says 1.0 volts, it is outputting 1 volt peak to peak. The way that I did that is I have this hooked up to one channel of the oscilloscope and my signal generator set to 1 volt peak to peak, both at 1 kilohertz. I fed them into the same scope, and the amplitudes are the same. Right now they're perfectly overlaid, but there's a slight phase discrepancy, so they're slowly moving away from one another in time. But the amplitude is correct, so this is actually 1 volt peak to peak when it's set to 1.0, and in my opinion that's the perfect test level. That's what I use for testing preamps all the time. 1 kilohertz, 1 volt peak to peak. All right, so I'm going to press run. Looks like it was already on. That must be what it's showing when it's off. Green on, so let's assume this generator is on, and then if I click that, I can get back to, that was a click and hold, I can get back to the oscilloscope, and there's a sine wave right there. But it's not triggering properly. It's a little bit too low in amplitude, and it's shaking back and forth. So I'm going to push the auto button and see how this does. So after running the auto, it worked, I can see it, but it's a little bit too low on the screen. So I can use this thing up here to change some parameters. So right now we have vertical and horizontal. So it looks like this button is doing our volts per division, and this one is doing our time base. So if we want to see more of the wave or less of the wave, we can use that top toggle, and then we can change how big the waveform is here in the vertical adjustment. So I'm going to go to mode, and this one, let's see what this is doing. The top one is adjusting the position of the waveform, and this adjustment is changing the position there, which is what I want. Okay, so now I've kind of got the waveform looking how I want. So this device is producing the signal that we are seeing here. So for example, if I push and hold and go back to the signal gen, and I turn it off, when we go back to the oscilloscope, there won't be anything there. All right, let's go back and turn that on. Oh, I click on it. It's not a touch screen. Run. Sine wave is on. Back to the oscilloscope. Okay, so now we know that this is outputting a test signal, and we're able to measure it with the probe. So let's get this set up again for feeding into the Denon preamp that we're testing and see if we can trace the signal through the circuit. All right, so once again, I'm just taking the probe off for now. I'm going to shove the booty up so that my tip is fairly insulated. That way it's not bumping up against the ground connection here, and then I just need to get my ground into here. All right, now that we're connected back, I just want to confirm that the signal is getting into the device and we have the same starting state. So as I turn up the volume on the device under test, we can see we have a signal and our symptom is still present. And if I was to disconnect one of these, we'll see one of the traces drop. So we're successfully feeding a signal from the little portable device into the device under test. I just removed all the screws from the top cover. Let's take a peek inside. This looks like a single board design. It should be pretty easy to find what we're looking for here. We have the power supply here. Looks like phono stage maybe in this area combined with some of the tone circuit maybe. This might be the noise reduction, I'm not sure. So we'll take a look at the schematic and see if we can come up with a good place to start probing. If you remember, looking at the block diagram, I wanted to verify that I have a nice signal at the output of the volume control. So if we look at the schematic, the volume control is shown here, and off of the wiper it goes through this 470 ohm resistor into this FET. So the easiest place to probe is probably on one end of that resistor. So I'm going to look around and see if I can find R201 and its counterpart, which is not shown in detail on the other side of this circuit, but it should be pretty easy. This is a symmetrical design on the inside. So I'll look for R201 and its counterpart and probe both of them. We'll see what we get. Okay, I've identified those resistors. They are here and here, and it kind of makes sense right off the volume control. There's some leads coming down. They go into the board right near these resistors, and then they're near the FETs there. So the first thing that I'm going to do is find a place where I can set this where it's not going to short on anything. One of the nice things, it has a little tip-up stand. Maybe I can put it somewhere in here. Somewhere where it's not going to short out against anything. There are metal parts on here that could short something out, so I'm going to be careful. And this first test, in theory, I should be able to do this without even powering the unit on, because this should be in the passive circuitry. At least that's what I'm thinking. So to make this a little bit easier to move around in here, I'm going to just connect a clip lead to the chassis and then clip it onto the probe here. That'll give me a little bit more flexibility. Okay, let's take this probe and see what we get on these resistors. And again, this unit is off right now. I've got my volume control all the way up. So we can see our signal there, and this is me turning the volume control. So that's looking good on that channel. Let's check the other one. and that one's fine too. So as I suspected, the passive section of the device is not the issue. It's something after the volume control. So this is a good baseline. Now I want to do that half splitting trick. I'm going to find a good point to probe that's in between the two active blocks that are after this and see if we can isolate it to one half of the circuit. So what I'm looking for is this point here where the high filter connects and brings it into the isolation amplifier stage. So the high switch is right here, so I'm going to look for R301 and see what the signal looks like at that location. The unit is now powered on, so what I did is I just took the top cover and set it here so that I could keep the oscilloscope signal generator device here outside of the chassis. And the resistors that I'm looking at are here and here, so again, pretty easy to get to. So if I just probe on this side of this one, it looks like my signal is good there, but there must be some DC on this. And I can see in the corner this is DC coupled, so let me see if I can figure out how to get this AC coupled. When a scope is DC coupled, it means that it's taking the DC component into effect and raising or lowering the position. That could have been why this was shifted initially at the beginning. So let me look into the menu and see if I can make this AC coupled. All right, let's look around in here. Maybe push and hold mode, there we go. Coupling. AC. All right, let's see if that's any better. I might need to change the position again. Interesting. Okay, well, let me work with the position. All right, I've got the probe sitting in there by itself, and let's see if we can get this looking better. So it looks like that change didn't really help changing it to AC coupling, but in any case, I'm going to get it showing correctly on the screen. So we're working with some gain here. So this is later on in the circuit, and it's part of the active section of the circuit. So let's try this. Change our volts per division. So we're showing fine on this channel, and it's still looking good on this channel. This is the volume all the way up. So what that means, if we look at the block diagram again, is that everything from this point forward is good. So we're now into this isolation amplifier. So really there's not much left of the circuit. So I'm going to look at the circuit itself, figure out which component I think is probably most likely to have failed, and we'll start there and see if we can get it even further nailed down. So now we're looking at the isolation amplifier section of the circuit. It's shown in this area, and then the other channel is duplicated here, and they just don't show it for simplicity. We've got some Zener diodes and transistors and FETs in the input section here. We've got some transistors in the output section, and then we have an integrated circuit in the middle. So I'm going to try to use that same strategy. I'm going to start in the middle at the integrated circuit. This is also the most common thing. Based on the symptom, this is the first place that I would look, is the IC. So it's a good place to start anyways. So it looks like we can probe at the inverted input of this op amp. So we're looking for pin 2, and then the negative on this side would be pin 6. So we'll make sure the input is good at pin 2 and pin 6, and if it's good, we'll move on to pin 1 and pin 7 and see if the signal coming out of this operational amplifier is bad on either of the channels. So I'll get set up and we'll probe those points. IC301 is right down in here, so it's going to be kind of hard to get on camera. You can see that pin 1 is shown by this little dot here, so I'll be able to count around the pins. So let me back this out. Okay, so I wanted to probe at pin 2 and pin 6. Let's try pin 2. I'm seeing a little bit of a signal there, but it's not very big. I took another look at the schematic, and I think this is actually in the negative feedback portion of the circuit, so I'm going to look at a different spot to probe here. Maybe it's not the IC. Okay, there's a resistor before that IC. It looks like the signal is coming out of the kind of the transistor and FET section in the front. So that's R115 20K resistor. I'm going to try to probe on both sides of that and see what I get. So R115 is here. That's the back side of it. That's what I'm seeing on the IC. Let's see what's on the front side. That's looking better. Okay, let's look at the other channel. Looks like this is arranged in a mirror image, so this should be my spot right here. And that's looking good as well. What's the other one here? Okay, so let me go further past that IC. Okay, looking a little bit further back in the circuit, this is R223. And that is where our issue is showing up. This is on the front side of that resistor. You can see it's a little bit deformed, but on the back side, it's really messed up. Its counterpart in the other channel is here. And that one looks fine on both sides of it. So really, I'm starting to suspect some of these transistors. So at this point now, I've got it isolated to a very small part of the circuit. So I'm going to go ahead and take off the bottom cover, start removing some of these parts and see if I can find the faulty component. So where I'm at right now is I'm suspecting one of these two transistors is bad. My signal is really not good on this side of the resistor. It's okay here, and it's fine here. So I haven't ruled out this IC. This could still be affecting it in some way, but this is pretty easy for me to diagnose, so I'm going to start here. My strategy here is going to be pulling each of these transistors and testing them. If they test bad, we'll know kind of what the issue is right away, but if these both test good, it could be that one of them is only faulty when it's in a certain operating condition. So to figure that out, I will take these suspected bad transistors, move them into this channel, and move the good channel's transistors into this one, and see if the issue follows. I've removed the first transistor. I'm going to go ahead and remove the second one as well. Okay, here's transistor 111. Fine. It's 113. Look at that. It's got like an extra diode between the emitter and the collector. I think this transistor is faulty. Let's go back to this one. Yeah, you see, that one tested fine, like a normal transistor, high beta. This is the suspect bad one, 113. Yeah, I think we have a bad transistor here. Found a couple of NPN transistors that have similar specifications and the same pinout as the ones that were in there, so I'm going to load these in and see if our issues result. Okay, the new transistors are in. Let's see if this solved the issue. And one note, I did power this down, so I haven't changed anything. Let's see if it's still in the same state. So let's check the good channel. Good. Oh, that's nice. So it didn't need any adjustment. It remembered where it was set. So that's good. Let's try the other channel. I think we've got it. Wow, that worked out great. So now what I'm going to do is use the same transistors that I put in the bad channel and match them up in the known good channel just so that they're both running the same parts. And then I'll retest and make sure everything's good. But it looks like we were able to find the issue using this as a little signal tracer. That worked out really well. I've loaded the alternate transistors into the other channel, and now we can do some verification testing. So I'm still using this device as the signal generator. And now we can go all the way up and both channels look the same. So that weird issue with the clipping on that one has been solved. So in that application of signal tracing, this thing performed perfectly. It did exactly what I wanted it to. I wouldn't use this to replace my bench signal gen because this is a little bit more precise. There's not a lot of adjustment on amplitude and stuff here, but just for creating a basic signal, it's great. And then the main thing I like about it is when I'm done signal tracing in the past, I'd have to hold my probe on something, and then as I crane my neck, sometimes I'll move my shoulder a little bit, you know, trying to look up at the scope, and then I'd lose my connection point. So this keeps the visual that you're looking for right on your work surface, basically. So, and then the battery powered capability is just an extra bonus, a little bit more safety that way. So I'm going to keep this thing around. I think I'll keep this in the drawer and use this for signal tracing in the future. If you're interested in purchasing one of these little guys for yourself, check out the video description and you'll see a link where you can pick one of these up. Thanks again for stopping by the channel. If you like this content, I'd invite you to like and subscribe, and we'll catch you on the next one.